Hi guys, welcome back to my channel. Today we're going to see the detailed solutions for the Cambridge International AS and A-Level Pure Maths paper, A-Level paper, May June 2022. So let's start off with the question number 1. So the question 1 says, solve the equation log of e power 2x plus 3 equal to 2x plus log 3, giving your answer to correct to 3 decimal places. This question is a concept of the exponential and logarithms. So log of e power x, e power 2x plus 3 equal to 2x plus log 3. This is a 4-mark question. You should be able to finish the solution in less than 4 minutes. Now, get the log 3 to the other side. So log of e power 2x plus 3 minus log 3 equal to 2x. Now, if this is of the type log a minus log b, so log a minus log b, you know the rule of logarithm is that log of a by b. So this will be log of e power 2x plus 3 by 3 equal to 2x. Now when you get rid of the logarithm, you get the exponential. Therefore, e power 2x plus 3 by 3 equal to e power 2x. Cross multiply the 3, so you get 3 e power 2x equal to e power 2x plus 3. When you get the e power 2x to the other side, 3 e power 2x minus e power 2x will give you 2 e power 2x equal to 3. Therefore, your e power 2x will be 3 by 2. When you take the logarithm, you get 2x equal to log of 3 by 2. Therefore, your x will be equal to half times log of 3 over 2. Now, the question says give your answer to 3 decimal places. Therefore, when you put this in a calculator, you would get 0.20273. Rounding out to 3 decimal places, it will be 0.203. So that's how you solve for question number 1. Moving on to question number 2, it's again 5 marks, 5 minutes. Now this is a trigonometric question with, with a trigonometry double angle here, cos double angle. You know the cos double angle formula. From the formula sheet, you can identify there are 3 formulas given to you, cos square minus sine square. And also you have 2 cos square theta minus 1 and 1 minus 2 sine square theta. So here, now you have to decide which formula or which relation you're going to choose. On the right, if you see, you have cos theta. So the best double angle you're going to choose is cos 2 theta is 2 cos square theta minus 1. If you choose this one, you would completely get a quadratic equation in terms of cos, whereby it will be easy for us to solve the equation. Therefore, when you multiply 3 into 2 cos square minus 1 equal to 3 cos theta plus 2, you get 6 cos square theta minus 3 equal to 3 cos theta plus 2. So try to get the terms on the other side. The 3 cos theta moving left becomes negative 3 cos theta. Minus 3 minus 2 will be minus 5. Now you can use the quadratic formula to solve this, because this is nothing but a simple quadratic equation. If your cos theta is x, then it will be 6x square minus 3x minus 5 equal to 0. So the quadratic formula will be minus b plus or minus root of b square minus 4 into 4ac by 2a. This will give you 3 plus or minus root of 9 plus 120 divided by 12. So 3 plus or minus root of 129 by 12. Now cos theta will get two values for you. 3 plus root of 129 by 2. The other one is cos theta is 3 minus root of 129 by 2. I'm sorry, 12. Now this value 3 plus root of 129 by 2, if you put in your calculator, you would get 1.196, and here you would get negative 0.69648. Now see here, this value is more than 1. But cos theta, as I said earlier, it can never be exceeding 1. It's always bounded between plus 1 and minus 1. Therefore, no solution for this value. So coming to this point, here cos is negative because he is a negative value. And if you use a small ASTC, the quadrant measures for the trigonometric ratios. Here you have what this diagram says is that cos is positive in um, the first and the fourth quadrant, which means negative in 2 and 3. In the second quadrant, it is 180 minus theta. Third, it is 180 plus theta. Before that, we have to also see the angle has been asked to measure in degrees only between 0 to 360. Therefore, you find the principal value of cos inverse of 0.69648. So you would get 45.85 degrees. Therefore, the final angle is 180 minus 45.85. The other one is 180 plus 45.85. Now this will give you 134.1 degrees, and this one will be 225.9 degrees. So these are the two angles that you need to finally get. So that's the solution about this question. Let's move on to the next question. So here this question is about the polynomial ax cubed plus x squared plus bx plus c. No doubt that this topic is the first topic of your A-level syllabus, algebra of the polynomials, where you also have the factor theorem and the remainder theorem and the modulus. So given p of x equal to ax cubed plus x squared plus bx plus 3. Now, if you read the question properly, it's divisible by, which means this is a factor. Therefore, according to the factor theorem, so 2x minus 1 is a factor, which means x equal to 1 by 2. Therefore, p of 1 by 2, there's no remainder. So remainder is 0. So p of 1 by 2 is 0. So plug in 1 by 2 in this. That's one condition. So you get a into 1 by 8. 1 by 2 whole cube is 1 by 8. 1 by 2 whole square is 1 by 4. And b by 2 plus 3 equal to 0. A by 8 plus uh, 13 by 4. When you add 1 by 4 and 3, you get 13 by 4 plus b by 2 is 0. Multiply the whole thing with 8. You would get a, multiply the whole thing with 8, you get a plus 26 plus 4b equal to 0. For a plus 4b equal to minus 26. Let's say this is equation 1. We also got another condition. The other condition is that x plus 2 when divided by x plus 2, the remainder is 5. Therefore, p of minus 2 is 5. So plug in minus 2 in the polynomial, you get minus 8a plus 4 minus 2b plus 3 equal to 5. Minus 8a minus 2b plus 7. So it's minus 2 divided by minus 2, you get 4a plus b equal to 1. This is equation 2. You have to solve these two equations now. What you can do is you can multiply this equation with 4. So you get 4a plus 16b equal to minus 26 into 4 is 104. Now 4a plus b equal to 1. Subtract both the equations. A gets cancels off. Here you get minus 15b. This is minus 105. Therefore, b is minus 105 by 15. You get minus 7. Since b is minus 7, we can find what a is. A plus 4b is minus 26. A, b is minus 7. A minus 28 equal to minus 26. Therefore, a equal to 2. Therefore, a is 2, b is minus 7. So, hope this question is clear. Now, let's move on to the next question. Now, if you see the equation, the curve is y equal to cos cube x into root of sin x. It is given that the curve is one stationary point in the interval. This is a open interval. Remember that there's no equal to here. So this is only in between 0 and pi by 2. You should be very, very careful on this, this thing. And also, this says only one stationary point, and we're looking for only the x coordinate. And also, we need we need the answer rounding up to 3 significant figures. Now let's find the differentiation of this. This is nothing but the differentiation concept question. Uh, Finding out the stationary point is already, this concept is of AS level, where the stationary points increasing, decreasing, maxima, minima, you learned in your AS level. To find the stationary point, the first step you do is you need to find the dy by dx. Let's first differentiate this. Now the differentiation of cos cube x into root of sin x. Now let's consider we're going to apply the product rule here. So let's say this is u and this is v. So u is cos cube x. So u dash, the differentiation of that will be 3 cos square x times minus sin x. We're applying the power rule and the chain rule here. So this gives you minus 3 cos square x sin x. Coming to the v, v is your root of sin x. Again, this is also the power rule. Root of sin x can be written as sin x to the power half, right? So going to first use the power rule here. So 1 by 2 sin x to the power minus half into, again, the chain rule. So sign differentiation is cos. So you would get this sin x to the power minus half is 1 by sin x to the power half into cos x. Therefore, right in a proper form, it is nothing but 1 by 2 root of sin x into cos x. So that's the details about the u and the uv and its corresponding differentiation. Therefore, your dy by dx will be uv dash plus u dash into v. U is cos cube x into the differentiation of v is 1 by 2 root sin x into cos x. Now u dash is minus 3 cos square x sin x into v is root sin x. And again, as you see here, this doesn't have the denominator. So the next step, we're going to multiply this 2 root sine x to this term. Therefore, you get, and cos cube into cos is cos power 4 minus, there's a 2 here, there's a 3 here, 2 times 3 is 6, root into root, root sine x, root x into root x is root of x squared, therefore it is x. Similarly, root sine x into sine x will give you sine x, and there's a one more sine x and cos square x. So this gives you a whole divided by 2 root of sine x. Now there is a cos square common, cos square x into cos square x minus 6 sine square x, will divided by 2 root of sine x. Now we have to equate this to 0. Now dy by dx is 0. Therefore, cos square x into cos square x minus sine square x, cos square x minus 6 sine square x by 2 root sine x equal to 0. This again goes off to the other side, becomes 0, which means you get cos square x equal to 0, because if a times b is 0, either a is 0 or b is 0. So similarly here, either cos square is 0 or cos square x minus 6 sine square x is 0. When cos x is 0, x is pi by 2. But pi by 2 is not included because it's given the open interval only between 0 and pi by 2. Therefore, the option we have is cos square minus 6 sine square equal to 0. So cos square x equal to 6 sine square x, or 6 tan square x. When you divide with cos square on either side, you get 6 tan square x equal to 1. So tan square x equal to 1 by 6. So tan x equal to plus or minus 1 by root 6. So here it's given in pi by 2, which means again you have to give the answer in radians, not degrees. So we have to change the calculator mode to radians. So find tan inverse of 1 by root 6s. Here negative is not considered, I mean it's not needed in the sense, because tan is negative in the quadrants 2 and 4, but we're looking for only between 0 and pi by 2, which is the first quadrant. Therefore, tan inverse of, see that your calculator is in the radian mode. So tan inverse of 1 by root 6 will be equal to 0 0.38759, rounding out to 3 significant figures. That's what it said. So it will be 0.388. So that's the final solution for this question. Let's move on to the next question. Now this is something to do with the to try to understand what concept is this. By sketching a suitable pair of graphs, show that the equation log x equal to 3x minus x squared has one real root. So what concept is this? This is something when you say dealing with one root, and also when you also look at the second part, that verify there's a root between 2 and 2.8. This is something relating to the numerical solutions. Numerical solutions. But before that, we need to sketch. See, it's asking only for a sketch. The grid is not given to you, but still what you have to do is you have to draw a proper graph here. So let's draw the x and the y axis. And yes, so mark the points. For example, 1, 2, 3, 4, 1, 2, 3. Just like marking the numbers. It shouldn't be because there's no grid here. You can also use your scale. But thing is that you should not spend too much time on it because we're looking for only a random sketch here. It doesn't mean that you should give a very weird sketch and all. At least if you can plot the points and show for the necessary points, it will be really good. So what does it mean for log x? We know the domain is only for x greater than 0, and when x is 1, the log is 0. So we can mark a point here, and we can draw a smooth curve for the log. That's how the log x graph is. Coming to the y equal to 3x minus x square, you can mark the x-intercepts by equating this to 0. X into 3 minus x equal to 0, therefore you get x equal to 0 comma 3. So you can mark 1.0 and the other 0.3. Also, if you complete the square, you can complete the square, or you can also find the vertex. The vertex is of course in between 0 and 3, which is 1.5. Therefore, you can also find the corresponding y value. 3 into 1.5 is 3 by 2 minus 9 by 4. So 9 by 2 minus 9 by 4. Half minus quarter is 1 quarter. So 9 by 4. So the vertex is simply 3 by 2 comma 9 by 4. Now I'm not going in detail like how to complete the square and all the stuff. This is the AS level concept. If you have any questions how to do it in a easier way, you can email me. Not an issue. Now we got the two vertices 0 and 3 and the vertex 3 by 2 and 9 by 4 is a value more than 2. So just join the points. So this is the sketch they're looking for. It's an open down parabola. Now after this, what you have to understand is that there is one root. The meaning of the one root here is the parabola and the log x graph, they intersect at only one location. Right? So this is how you work it out. Now verify by calculation the root lies between 2 and 2.8. You have to show there is a sign change. Before that, consider f of x is equal to log x. The equation is given as log x equal to 3x minus x square. So bring it the terms, the x term and the x square to the other side, you get plus x square minus 3x. Now plug in these values 2 and 2.8 and check for the sign change. So when you plug in 2 in log log x plus x square minus 3x, so when you plug in 2, what you would get is minus 1.3068. This is a negative value, and for 2.8 you get 0.4696. This is a positive value. Since there's a sign change, f of x changes its sign from negative to positive, from negative to positive. Therefore, there is a root. Therefore, there is a root. So that's how you work it out. Now moving on to the iteration formula. The iteration formula has already been given to you. You need not frame it. You can start off with the initial value x1, either 2 or 2.8. All that you're going to do is, I'll just show for one value. Um, so here, when you plug in n equal to 1, you get x2 equal to, you'll get x2 equal to square root of 3 into x1 minus log of x1. So that will give you 3 into 2 because x1 is 2. So 6 minus log 2. So that value you will get 2.3036x. Now in calculator what you do is you can just give the input value to and then cancel it, and then press 2 and then equal to, then cancel it, then click answer in your calculator, check if in the answer mode answer is showing you 2 or not. After that, input in your calculator square root of 3 times answer, because every time whatever the output you get becomes the input for the next iteration. So 3 times answer minus log of answer. If you do this and keep clicking on the equal to every time, you will be shown the iteration values. So x4 is 2.5481 and 2.5901, and x6 is 2.26112, x7 2.6218. So x6 is 2.6112, x7 is 2.6218, and x8 will be 2.6270, x9 2.6297, x10 2.6310, x11 2.6316, 6316, x12 is 2.6319, then 2.6321, then it is 2.6322, 2.6322. You might be wondering at one point after you started iteration, where have to stop? You have to continue. You're not going to do any mental math here, only the calculator. So keep clicking on equal to every time, and wait until you find two iteration value match. At that moment, you can say, yes, so this is my x value I'm looking for. Now we have given the iteration to 4 decimal places as instructed in the question. Finally, we need to round it to 2 decimal places. So your answer is 2.6322 rounded to 2 decimal places will be 2.63. So this is how you work it out. So let's move on to the next question, question number 6. Now, as you see here, the name itself is a differential equation concept. It's already given there. Now, this is a model where the equation is already given to you. You need not frame any equation, as sometimes it happens with some word problems. So here the equation is already given to you, and also the condition is given, the initial condition. So let's solve this. Dy by dx equal to x e power y minus x. Before you solve this, see that you separate the variable. So you can write e power y minus x as e power y by e power x. Now you can separate the variable. So dy by e power y equal to x by e power x dx. Now if you have e power x in the denominator, you won't be able to solve this integration, in the next step that you're going to do. So make it like a proper format of writing e power minus y dy equal to x e power minus dx. Now the variables got separated, hence start integrating on either side. So here the exponential integration is minus e power minus y. So you have to know what method you're going to do the integration here. Here all that you're going to use is the integration by parts. Integration by parts. So the integration by parts method is integral uv. If you have u as the differentiable function and v is the integrable, then the bypass method is u times integral v minus integral of v times the differentiation of u whole integral. Here in this case, your u is your differentiable function and e power minus x of v. Therefore, x integral e power minus x minus integral of e power minus x times the x differentiation, the whole integral. So that will give you x into minus e power minus x minus e power minus x differentiation 1. So minus x e power minus x plus integral of e power minus x, that will also give you a minus x e power minus e power minus x plus c. For your information, I'm writing integral of e power ax is e power ax by a. A is minus 1 in this case. So let's use the initial condition x0, y0. So plug in x equal to 0, y equal to 0 in this. So there's a minus here. So minus e power 0, 0 minus e power 0 plus c. Minus 1 equal to minus 1 plus c, therefore c is 0. Therefore, minus e power minus y equal to minus x e power minus x minus e power minus x. Let the minus e power x common, e power minus x common, you get x plus 1 here. 1 second. So please go look at the question. So what they're asking for is x plus y in terms of x, very important. So x plus y in terms of x, that means you should get like y as a subject of the formula. So you can get to this negative here. Therefore, when you take the logarithm on either side, this becomes minus y equal to log of e power minus x into x plus 1. So that will give you minus x plus log of x minus x plus 1. This is minus y. Therefore, y equal to x minus log of x plus 1. This is what we are looking for, and that is what the solution is. Now let's move on to the next part. He's saying hence find the value of y when x is 1. We already got what y is. Y equal to x minus log of x plus 1. So plug in simply x equal to 1 in this. You would get 1 minus log of 1 plus 1, which is 1 plus 1 is 2. 1 minus log 2. Where a and b is already given the format, expressed in the form of a minus log b. So 1 minus log 2. So done with this question now. So this is question number 7. This is again, you see dy by dx, it's a differentiation. What differentiation is this? This is an implicit differentiation because you have x and y together. The cases, the conditions or the equations where y cannot be expressed in terms of x, we call them as implicit. There's also another case where x and y are expressed in a new variable, a different parameter. That's called parametric equations. Anyway, here, let's see how we can differentiate this now. So apply the differentiation straight away. Differentiation of x cubed is 3x squared. And apply the product rule here. 3x squared into y differentiation is, so dy by dx. And y into 3x squared differentiation is 6x. Minus y cube differentiation 3y squared into dy by dx equal to 0. Remember, the differentiation of constant is 0. So bring all the dy by dx as common. So you have dy by dx into 3x squared minus 3y squared. When you take the terms to the other side, you get minus of 3x squared plus 6x. So your dy by dx will be equal to, take out minus 3 common, you get x squared plus 2xy by, again you can take 3 common in the denominator, 3 into x squared minus y squared. Cancel the 3 and the 3. Therefore, and also impart this negative to the denominator. get x square plus 2xy by y square minus x square. So this is how you going to get the differentiation dy by dx equal to x square plus 2xy by y square minus x square. Now, find the coordinates of the points in the curve where the tangent is parallel to the x-axis. Tangent is nothing but a line, and which is dy by dx. The gradient of the x-axis is 0, but the tangent is parallel to it, therefore dy by dx is 0. That's how you frame it out. Therefore, here looking for the points where dy by dx is 0, which means you have x square plus 2xy by y square minus x square equal to 0. When you multiply here, that becomes 0. Therefore, x square plus 2xy is 0. Take out x common. You get x into x plus 2y is 0. Therefore, you get x equal to 0 and x equal to minus 2y. But how you're going to deal this and how you're going to solve this? So what we're going to do is we have a main equation x cube plus 3x square y minus y cube equal to 3. So plug in x equal to 0 in this. 0 cube 0. 0 and anything is 0. Minus y cube equal to 3. Therefore y cube or minus y cube equal to 3. Therefore y cube is minus 3 and y will be equal to minus cube root of 3. Therefore the point is 0 comma minus cube root of 3. This is one point. For the second point, we have plugging in x equal to minus 2y in this, you get minus 2y whole cube plus 3 into minus 2y whole square into y minus y cube equal to 3. This is minus 8y cube. This will give you 12y cube minus y cube 0. 12 minus 9, 3y cube equal to 3. Y cube equal to 1, therefore y is 1. When y is 1, x is minus 2y, therefore it is minus 2. Therefore the other point is minus 2 comma 1. So these are the 2 points we are looking for, minus 2 comma 1 and 0 comma minus cube root of 3. All right, that's a solution. So let's move on to the next question, which is the partial fractions. It's already given. Here it's partial fraction concept. And this is of the type bx plus c. Therefore, this can be written as x square plus 9x divided by 3x minus 1 into x square plus 3 equal to a by 3x minus 1 plus bx plus c by x square plus 3. So now let's simplify this. A into x square plus 3 plus 3x minus 1 into bx plus c. The whole thing should be equal to x square plus 9x. Remember, there's a denominator here. There's also a denominator there. You can cancel them. Therefore, you have x square plus 9x equal to a into x square plus 3 plus 3x minus 1 into bx plus c. I can go for random x values. The best x value you can go for is x equal to, when you equal that to 0, you get x equal to 1 by 3. So plug in the x value here. So you would get a into 1 by 9 plus 3. This becomes 0. Therefore, 27 plus 1, 28 by 9 equal to 28 by 9 into a. From this you get a is 1. The next possibility is that you can go for the x value 0. When x is 0, you get 0 on the left. So 3a minus of c. A is 1, so 3 minus c 0. Therefore, you would get C is. After this, you can go for a random x value 1. If you go for 1, x square plus 9x will be 1 plus 9 is 10. You get 4a plus 2 into b plus c. We know the value of a. A is 1, so 4. 2b, 2c. C is 3, so 2 into 3 is 6. So you get 10 plus 2b, 10, 10 cancel, therefore b is 0. Therefore, your f of x, the partial fraction will be a is 1 by 3x minus 1 plus b is 0, bx, so 0, c 3, so 3 by x square plus 3. So this is how you work on the partial fractions for this part. So let's move on to the next part. Hence find, okay, now hence find. So whatever you got in the partial fractions, you're going to consider that. Basically use the first part to integrate here. Now integral of a is 1, so 1 by 3x minus 1 plus 3 by x square plus 3. Now this is nothing but 1 integral of 1 by 3x minus 1, and 3 is a constant, so pull it out, 1 by x square plus 3. Now this is very simple. This is the type 1 by ax plus b. So 1 by x integral is log x, log of 3x minus 1. Please do not forget to use the reverse chain rule, because there is a constant 3 there. So times 1 by 3 plus 3. Now this one is what you have to be little cautious. The 3 can be written as root 3 square. Remember, by default there's a dx there. Do not forget to write during the exam. So here, integral of 1 by x square plus a square, if you look at the MF19 formula sheet, you will quickly notice it is nothing but 1 by a tan inverse of x by a. Need not worry what it is. The only thing that you have to do is make 3 as root 3 square. Therefore, this is 1 by 3 log of 3x minus 1 plus 3 into a is 1 by a is root 3 here. So 1 by a, 1 by root 3 tan inverse of x by root 3 with the limits 1 and now plug in the limits here. So you get 1 by 3 log. When you plug in 3, you get 3 3 is a 9 minus 1, 8. 3 by root 3 is root 3. Tan inverse of 3 by root 3 is again root 3 minus. Now plug in 1. 1 by 3. 3 into 1, 3 minus 1, 2. So log 2 plus root 3 tan inverse of 1 by root 3. Therefore, so let's spread this 1 by 3 log 8. Tan inverse of root 3 is, so here they're asking you to give the answer in the exact form. Now, when you're asked to work when you're dealing with these kind of situations, please do not be in a hurry and put the, for example, tan inverse of root 3 when in calculate in the degree mode, you get 60 degrees. Please do not use that. We cannot mention the real values along with the degrees. So the best mode is the radian mode. So put the calculator in the radian mode or check if it is in the radian mode. So tan inverse of root 3 in the radian mode will give you pi by 3. And here you have minus 1 by 3 log 2 minus root 3. Again, tan inverse of 1 by root 3 is pi by 6. Combine these two, log a minus log b. Therefore, log of a by b Now root 3 common. So pi by 3 minus pi by 6. Now pi by 3 minus pi by 6 is nothing but basically 60 minus 30, which is 30 degrees. See, if you have a very good uh, smart calculations within you, it's well appreciated, but never take any chances. Please use calculator. So pi by 3 minus pi by 6 will give you pi by 6. Now here log 4 is nothing but log 2 squared. And log of a power m is m log a, 2 log 2. So 1 by 3 into 2 log 2 plus root 3 pi by 6. The final answer will be 2 by 3 log 2 plus root 3 pi by 6. So this is how you get the solution for the question 8. So looking at this question itself, it's nothing but vectors. The lines L and M are vector equations. Given that L and M intersect, show that 2b minus a equal to 4. Do not worry. This might seem like a little tricky question for you. People find it is a little hard like that. I don't think so. So please do not jump onto conclusions thinking it's hard. You know what is the concept involved when line and M, when two lines intersect? First thing is that going to equate the two lines, get the three equations, take any two, solve them, and once you solve for the lambda and the mu, the parameters, going to plug it in the third equation. Same logic going to apply here. So the first equation R bar is minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. Second equation is 5 plus a mu, 4 plus b mu, and 3 plus mu. Equate these two lines. Minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. When you equate, you get minus 1 plus 2 lambda is 5 plus a mu, 3 minus lambda is 4 plus b mu, 4 minus lambda is 3 plus sorry, excuse me for that. Now from this, what you can do is, you will get the equation 2 lambda minus a mu equal to 6 is equation 1, and lambda plus b mu, you can check the working, lambda plus b mu equal to 3 minus 4, so you get minus 1, and lambda to the other side, 3 to the side, you get lambda plus mu equal to 1. So these are the three set of equations we got. So what we'll do is, let's take the last two equations and solve for the lambda and mu. Lambda plus b mu is minus 1. Lambda plus mu is 1. Subtract the two equations. Lambda gets eliminated. Change the signs. So mu into b minus 1. Lambda mu into b minus 1 is minus 2. Therefore, your mu is minus 2 by b minus 1. You already have what lambda is. Lambda from this equation is 1 minus mu. So 1 minus minus 2 by b minus 1, which is 1 plus 2 by b minus 1. So you get b minus 1 plus 2 by b minus 1. Therefore, it is b plus 1 by b minus 1. We have one equation left out, which is the first equation. Consider that equation and plug in the lambda and the mu value in this. So lambda is b plus 1 by b minus 1 minus a into mu is minus 2 by b minus 1 equal to 6. The denominators are same, so b minus 1. So this becomes 2b plus 2 plus 2a equal to 6. Cross multiply this. So 2b plus 2a plus 2 equal to 6b minus 6. Move all the terms to the other side by making a sign change. 6b minus 2b is 4b. 2a to the other side minus 2a. Minus 6 minus 2 minus 8 equal to 0. Divide by 2. 2b minus a minus 4 equal to 0. Move 4 to the other side. Minus 4 to the other side. 2b minus a equal to 4. This is what you're asked to show that. Now, given also that the two lines are perpendicular, so in this case, you're asked to find the values of a and b. Therefore, um, let's look at the directions of the two lines. It is 2 minus 1 minus 1, 2 minus 1 minus 1 times the other direction is AB1. So AB1 equal to 0. When two lines are perpendicular, the dot product is 0. Alright? That's the reason we're doing the dot product to 0. So 2a minus b minus 1 is 0. Therefore, 2a minus b equal to 1. So let's say this is equation 2. We already got an equation in the earlier part, 2b minus a equal to 4. 2b minus a equal to, so this is the equation we got in the earlier part. What you can do is you can multiply this with 2, you get 4b minus 2a equal to 8, and use this equation here. It is minus b plus 2a equal to 1. Add the two equations. 3b is 9, b is 3. You can easily find out what a is. 2a from this equation, 2a minus 3 is 1, 2a is 4, a is 2. So when a and b have these values, find the position at the point of intersection of L and M. So we already got the values of lambda and mu, but in terms of a and b, or mostly b, I'll say. Lambda we got um, b plus 1 by b minus 1. B plus 1 by b minus 1. What is b? B is 3. So 3 plus 1 by 3 minus 1, which is 4 by 2, which is 2. You already know the first equation in terms of lambda, and that is minus 1 plus 2 lambda minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. Plug in lambda 2 here, you get minus 1 plus 4, 3 minus 2, 4 minus 2. Therefore, you get the point of intersection is 3, 1, 2. So you work out for the point of intersection of the lines L and L. Let's move on to the next question. So this is of course, it's very straight. What concept is this? Is it complex number concept? And it's given u equal to minus 1 plus root 7i. And it says that u is the root of the equation, hence find the value of k. K is a real constant. It's neither positive. I mean, it can be either positive or negative. It's a real constant. Sometimes they may specifically mention it's positive, then that means you have to work out only for the positive value. Here in this case, it can be anything. Now, what is the first step going to do? You're going to plug in this u in this equation and equal to 0, then find the k value. So let's find what x cube is. Before that, you can find what x square is. X square is minus 1 plus root 7i whole square. That will give you 1 minus 7 minus 2 root 7i, which is minus 6 minus 2 root 7i. This is your x square. Now, if we want to find x cube, you multiply x square with x. So x square is minus 6 minus 2 root 7I times minus 1 plus root 7I. Minus 6 into minus 1 is 6. So minus root 2, 2 root 7, root 7. 2 sounds at 14. There's a minus. I square is there. Again minus, 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 plus. That gives you 14. The multiplying the I terms. This will give you positive 2 root 7I, and this will give you negative 6 root 7I. So which means you would get 20 minus 4 root 7. Now plug it in the equation. 2 into x cube is 20 minus 4. 20 minus 4 root 7I. 3 into x square minus 6 minus 2 root 7I plus 14x minus 1 plus root 7I plus 3 equal to 0. So this gives you 40 minus 8 root 7I minus 18 minus 6 root 7I minus 14 plus 14 root 7I plus k. Minus 8 minus 6 minus 14 minus 14 plus 14 cancel. So the I gets cancels out. Get 40 minus 18 minus 32 is, minus 18 minus 14 is minus 32 plus k equal to 0. Therefore k is minus 8. Now find the other two roots of the equation. Since it is always said that one root is minus 1 plus root 7I, the next root will be its conjugate, which is minus 1 minus root 7I. Also, I want you to make you recall something what you learned earlier. Let's say if you say x equal to 2 is a root, then we say x minus 2 is a factor. The same logic will apply here. X plus 1, since x equal to 1 minus 1 plus root 7I is a root, we say x plus 1 minus root 7I is one factor. X plus 1 plus root 7I is another factor. Since we have two linear factors, let's multiply them. X plus 1 minus root 7I, x plus 1 plus root 7I. Now this a minus b times of a plus b gives you a square minus b square. So x plus 1 whole square minus root 7I whole square. So that will give you x square plus 2x plus 1 plus 7. Why 7 plus 7? Because you get 7I square here. I square is minus 1. There's a minus here. Minus of minus 7 plus 7. Therefore, this will give you x square plus 2x plus 8. Now you got a quadratic expression. You can divide the polynomial. Uh, so the polynomial is 2x cube plus 3x square plus 3x square plus 14x plus 14x, k is minus 8, divided by this x square plus 2x plus 8. So the leading term is 2x cube, the leading term is x square. 2x cube x square is 2x. 2x cube 4x square plus 16x. You know, the first when you divide, you get the quotient here. You're going to multiply this quotient with all the terms and place it over here. Then subtract, change our signs. Then add. Get minus x square, minus 2x, minus 8. The next option you have minus 1. Again, when you multiply with minus 1, you get minus x square, minus 2x, minus 8. The remainder is 0. Therefore, the other root is x equal to minus 1 minus root 7I. This is a factor, but you're looking for a root. Therefore, x equal to 1 by 2. X equal to 1 by 2 is the other. Oh, this is clear. Now, on an organic diagram, sketch the locus of the points representing the complex number z, satisfying the equation z minus modulus of z minus u equal to 2. The meaning of this is there are points in the plane such that the distance from this u is fixed, which is nothing but this simply a circle. So now you can go for a drawing a circle. Now this is a circle. Now this center, because the center u is nothing but is already given like um, minus 1 comma root 7, and the radius is 2 units. So this is minus 1 is the center. So your y-axis will be somewhere here, and x-axis is a little bit down the circle. Why? Because you can check in a calculator, root 7 value is more than 2, some 2.6 or something like that. So this is, let's say this is 1, this is 2, that's 3. Approximately, let's say this point is root 7. That is root 7. And this x value is minus 1. So they're asking to just sketch the locus of the points representing the complex numbers. Z is satisfying the equation, which is nothing but simply just a circle. Now, any point on the circle is a locus of the points that represents this condition. Oh, this is clear. This is simple. What next we have? Determine the greatest value of the argument of z for points on this locus, giving your answer in radians. Now, we need to draw the locus here in the sense like we need to find the greatest value of the argument of z. So how do you do that? So we have to draw the line first. Right. So now draw a line touching the circle and the origin. Draw a line touching the circle there. Now this is the radius, 2 units, because it's given the radius of the circle. It's only 2 units there. Now also we can join this. Now what is it they're asking for? Remember, the argument is nothing but the angle, the greatest angle they're looking for. So the greatest angle they're looking for is um, the greatest angle is this, till that. What is the angle we need? Therefore, how do you find that now? We know this angle is 90, pi by 2. So we can also calculate this angle, which is nothing but the argument of the complex number. We know it is minus 1 plus root 7i. So this angle will be using trigonometry is the tan inverse of, ignoring the signs, tan inverse of 1 by root 7. Yes, gives this angle. Now how do you calculate this angle? Now let me show you, let me show you a bigger version of this. So this is 1, this is root 7. Now this is the radius of the circle too. Now we can apply the Pythagoras theorem to find what this value is. That is nothing but root of root 7 square plus 1 square, which is root 8, which is 2 root 2. Now, the radius and tangent are perpendicular. Circle property is IGCSE. So this is 2 root 2. So I can find also what this is. Um, I can find that, or I can also use the simple Sokotawa. So for this, I also knew for this angle, this is opposite and hypotenuse. So the greatest value of the argument of the z is the angle 90. So this is 90, which is pi by 2 plus tan inverse of 1 by root 7 plus sine inverse of 2 by 2 root. So pi by 2 tan inverse of 1 by root 7. Sine inverse of 2 by root 2 is sine inverse of 1 by root 2, that is pi by 4. So that's the reason I was talking about. If you can find this by using again the Pythagoras theorem, this is an isosceles triangle, right angle isosceles. Obviously, this will be pi by 4 and pi by 4. That we also can measure what the angle is. So this will give you the final solution. Sorry for writing over there because the diagram we had there. When you're working on the paper, since you are on the same page, you'll be able to access it. I was like scrolling up and down, so I was using that space to show you the diagram and then use all those calculations. So the greatest value of the argument of z will be simply it's pi by 2 plus pi by 4 plus tan inverse of 1 by root 2. This is nothing but 3 pi by 4 plus tan inverse of 1 by root 2. So this is asking to give the answer in radians. Therefore, you can uh, the answer when you put this in the calculator 3 pi by 4 plus tan inverse of 1 by root 2, you will get 2.7175 rounding up to, there's no rounding here, give your answer in radians, that's it. So this is nothing but 2.7175 or 2.72, three significant figures around. That's it. So this is how you solve for the greatest value of argument of z. In this paper, that is May June 2022 paper, calculating the argument, the greatest value of the argument is simple because you are given only one circle there. Now let's say you have two circles or maybe another argument given to you, which is nothing but a straight line. Then, yeah, or if the line is passing through the circle, then you have to use some geometric skills to finally find out what actually the greatest value of the argument of G is. It needs just a bit of geometrical skills and smart thinking. So, but if you're able to split the diagram into pieces and work it out, you will definitely get the solution. I hope the solution is clear for the complex numbers. Very, very important and really good question. This question is really good. The geometry and all the diagrams and everything. All right, so that's all uh, the detailed solutions of the May June 2022 A-level pure maths paper. So again, I'm asking you if you like the video, please subscribe, give a like, and comment on it. Thank you.